thank everybody for joining our webinar and give a brief introduction as we go through this next generation connectivity for universities and exploring the power of 400 gig ZR+. So I'm Vince Schuele. I'm the Director of Partner and Customer Engineering here at IP Infusion, based out of Germany. I'm joined by Marian and Łukasz, and I'll give it over to Marian now to give a brief introduction, then Łukasz, and then we'll get started.
Of course. Thank you, Vince, and welcome everyone. And I'd like to start this by saying happy birthday to Vince and Łukasz. They are both celebrating their birthday today. And I'll continue with a few words about me. My name is Marian Polojan, and I'm in my role as Senior Hardware Product Manager with IP Infusion. I deal on a daily basis with open networking and 400G ZR+. Now, I think that open networking, it's game-changing, especially because of the fast innovation and flexibility. And when I speak about flexibility, I pretty much refer to the enablement of multitude of solutions. You'll see in the slides that we will present further that we already validated many 400G ZR+ switches from our partners, UFSpace and EdgeCore, and of course we validated with those many optics 400G ZR+ from Sienna, NEC, Coherent, Hisense, and Fujitsu. And this will be addressed in the future slides. Łukasz, over to you.
Thank you, and my name is Łukasz Łukowski. I represent STORDIS. We are partnering with IP Infusion as one of the partners, distributor. I am quite familiar with the open networking technology. I had a pleasure to working to one mentioned hardware vendor, EdgeCore Networks, in the past for almost 7 years. So happy to be there. And once again, Vince, all the best during your birthday.
You as well. And now we'll go ahead and pass it back over to Marian to go through what we're hitting today.
Of course. Thank you, Vince. So we'll start with the objective of the webinar, and that would be to get everyone familiar with the 400G ZR+ technology, and of course to present our solution. We will speak about the drivers for 400G ZR+, where we will touch topics like the increase in the traffic demand, how 400G ZR+ enable new deployments, new technologies, and of course, what is ZR and what is OpenZR+. We will continue introducing our proposal, where I will speak about the software component, which is called OGNOS, and 400G ZR+. And I want to mention here that OGNOS is specifically designed for disaggregated networking and is built to support high performance, high scalable networks in a variety of environments, including telecom networks and of course data centers. I will explain the capabilities of OGNOS when it comes to configurations, both for host and media components of the optical transceivers, via CLI and via netconf, laser tuning, and in-depth monitoring when it comes to alarms, laser specs, and many other parameters. We'll have Łukasz, who will continue with the hardware component of the solution, detailing about the available switches and soon to be available. And he will present also the already qualified 400G ZR+ optical modules, going into details about the optical parameters. He will speak about the launch power, receive sensitivity, optical budget, and of course, reachability. On the real world use case, we'll have Vince, who prepared for us a demo, and he will configure a DCI solution, a Data Center Interconnect solution, with 400G ZR+ optical modules and routers using OGNOS. All right, moving on.
Maybe before we will start, yeah. Marian, maybe just one important information to add. Any of you who would like to ask any questions, please feel free. There is a question section where we will try to also address all your questions later on today.
All right, thank you for that, Łukasz. Now, continuing with the drivers for 400G ZR+ solutions. First of all, the 400G ZR+ are coherent optical modules, which are designed specifically for high capacity and cost-effective data center interconnect over metro and long-haul distances. Now, of course, the first driver for that is going to be the growing demand for bandwidth. We have the hyperscale data centers, cloud service providers, and of course, ISPs, which require higher data rates to interconnect data centers efficiently. The leaders when it comes to high bandwidth consumptions, we have applications like AI/ML workloads, we have 8K video streaming, and of course, real-time analytics. The second driver is going to be the simplified network architecture. And we introduce here IP over DWDM. Now, 400G ZR+ integrates the coherent optical modules into routers, eliminating the need of the separate DWDM transponders. Okay, now the benefits of IP over DWDM are first, reduce latency, second, reduce operational complexity, and third is going to be the lowering the cost. I'm pretty sure taking out the traditional transponder is gonna be a big hit for the capex. Now, I need also to mention here that 400G OpenZR+ technology supports also RODM, networks for flexible wavelength configuration and management. All right. The third driver is going to be the green networking. Now, coming back to the point where the traditional transponder is eliminated, you will see that there is a huge power save. That while the traditional DWDM transponder was consuming around 60 watts, I would say, yeah, the new 400G ZR plus high power modules are consuming up to 24 watts, while the 400G ZR, yeah, the power consumption for them it's even lower. It's down to 16 watts. Okay, and closing on this, the national research and education networks may benefit as well from all disadvantages offered by 400G ZR+ technologies from the same reasons. The same, it's going to be scalable bandwidth for data intensive research. You have lower cost compared to traditional optical networks. You simplify operations with router integrated optics and flexibility. And from the flexibility point of view, you have the, as I said, you have the 400G ZR, which can be used for campus interconnects and connecting regional research hubs, because the amplifier reach for 400G ZR is 120 kilometers, and you have the 400G OpenZR with a reach of nearly 2000 kilometers. We will see this amplified distance. And the use case for this is going to be national and international research, interconnecting national and international research networks. Okay, now when it comes to the picture on the right side, it's something that I already addressed. On the upper side, you have the traditional OLS deployments where you have the router with the typical client optics, which connects via a gray light to the client optics of the transponder, and the transponder with its roles, signal conversion, optical modulation, signal amplification, and of course you have the signal tuning. On the bottom, it's what we bring to the picture, the new deployments, the deployments with 400G ZR+, and of course with using the same OLS networks, the same OLS deployed networks. And you see here that the ZR+, the ZR+ transceiver is going to take fully the role of the transponder. Okay, and all the roles, all the functions of the transponders are done by the router together with the ZR+ transponder.
Marian, there's a question about needing EDFA, and I think that depends solely on the distance that you're trying to go. So we'll see that in the power budget slides later on.
So yes, I can take the question. I see the questions if we still need EDFAs in these cases. Yes, we still need the EDFAs. I mean, the distances that I said earlier, the 120 kilometer, that refers to the amplified, yeah. But there are some optical modules, the high power ones, which already have EDFAs inside, yeah. And they have also tunable optical filters, TOFs, in order to shape back the signal. Okay, but Yeah, even if it's inside, it's just to amplify the signal, but you will still need EDFAs. Definitely, yes. Okay. Now we're coming to the differences between the ZR and OpenZR Plus. Now I already mentioned this, that both 400G ZR and OpenZR Plus are coherent optical transceiver standards designed for high-speed 400G DWDM transmissions. However, they will differ into features when it comes to features, flexibility, and use cases. And as you can see, when it comes to standardization, the 400G ZR is managed by the OIF, and while the 400G OpenZR is managed by the OpenZR Plus, which is an MSA. When it comes to the line rates, for the 400G ZR, you have a fixed 400G line rate, while for the OpenZR Plus, you have 100. You have support for 100, 200, 300, and 400G. When it comes to modulation, it's more or less the same. For ZR, you have fixed 16 QAM, while for OpenZR Plus, you support QPSK, 8 QAM, 16 QAM. And there are some cases like, I want to mention here the Sienna plugs, where they use also PCS 16 QAM. Yeah? PCS stands for probabilistic constellation shaping. And that's actually what makes their plugs going to so big distances, yeah, nearly 2,000 kilometers unamplified. All right, sorry, nearly 2,000 kilometers amplified. All right. I already mentioned the reach, 120 for ZR, and that's amplified, and 400, and for the OpenZR Plus, as I said, nearly 2,000 kilometers, yeah, amplified. Yeah. So with the use of EDFAs. Now the use case for the ZR, it's DCI for campus and regional interconnects, and for the ZR Plus is gonna be for the metro and long haul use cases. On the power consumption side, the ZR is gonna consume less, up to 16 watts, and the ZR Plus is gonna consume up to 24 watts. That's the maximum. And I mentioned here, I say here the maximum because, well, the power consumption is influenced by, you have few factors like the transmit power, the modulation, and I think the line rate also comes into play when we speak about the power consumption. All right. I want to continue now with our proposal. Yeah, and our proposal starts with the software component, and that would be the OGNOS. Okay. Now, as pioneers, because we are at IP Infusion into open networking, we find ourselves in the position where we have to fast implement standards like CMIS. Okay. Now, I don't know how many of you are familiar with CMIS. I'll just make a brief introduction what CMIS is. And actually, it's a standardized protocol developed by OIF to manage and control pluggable optical and electrical modules. So both optical and electrical modules are addressed by CMIS. Now, CMIS provides an uniform interface for initializing, monitoring, and managing the modules across various switches and routers. Okay, now OGNOS provides a very comprehensive support for CMIS, and that makes our solution very, very easy. It's actually a plug and play solution for any 400G ZR Plus module, which follows the 400G MSA, 400G ZR Plus MSA and CMIS guidelines. Well, what can be done with OGNOS? Well, advanced configuration. We provide full control, full configuration of the host and of the media of the pluggable inserted into the router. You are able to change also between supported applications because you'll have different modules with different applications. Yeah, you will see Vince actually. He will play with. I think you'll configure the first, which is going to be for your plugs default 400G ZR, and after that, I think you'll select a different application from there. 3x100G. Okay, that's the flexibility of 400G ZR Plus. What else? When it comes to channel spacing, for ZR, we support it's supported, that's supported by the standard, the 75 gigahertz and 100 gigahertz fixed grid. For OpenZR, we support flexible spacing for 37.5, 50, 75, and 100 gigahertz. We also provide support for monitoring, alarms, temperature, laser specifications, and many others. I want to mention here the support for OpenConfig data models, OGNOS being amongst the leaders when it comes to netconf support, especially for the 400G ZR+. All right, I think it's over to you, Łukasz, now.
Thank you. My part is really easy, and I would say the most exciting for the people who love hardware. So at IP Infusion, as you can see, there is a lot of models which are able to support ZR and ZR+. And focusing on that ZR+ up to 24 watts, on that slide, you see already 3 switches which are available. 2 are coming from EdgeCore Networks, another is coming from UFI, different port count, yeah. Of course, with that ZR+, we are primarily talking about 400G. So either it could be like a fully 32 400G or 64 times 400G. But later on, when we will go also to some routers, you will see that there is a combination of a different port count. As I say, there is a few models. Let me maybe bring an example of that one. First one, DCS 240 from EdgeCore Networks. That switch is powered by the Trident 4. So still, I am saying switch, but really powerful switch, because Trident 4, especially in that X11, is really powerful. Okay, we cannot run it as a full router with all the tables and buffers, but definitely it is not the Tomahawk family and not the Trident 3, which you know. So we can do far more. And that model in specific is capable to support even up to 16, such as ZR class modules. As you can see, it is marked on, I hope that I am not mixing the color, I am colorblind, let's say yellow. So all those top interfaces can do that. There are also some models on the Tomahawk 4, and even coming soon, both vendor, UFI space and EdgeCore. The porting is in let's say coming soon. We will see 64 times 400G, 800G switches, and those models can also support ZR+. So when we will jump to the 800G, even that required budget is going up of those 24 watts to the 30. So we will see when the porting will be available. It is like a Vince, as I remember, next release. Yeah, am I right?
It's currently planned in the roadmap for the summer for
exactly
661 release.
And then we will see how many interfaces could be supported. It is more than related with the hardware vendor, but some of them claim that any interface could support up to those 30 watts. So that is really exciting. And let's jump to the next slide, please. So here we see a combination of access and aggregation routers. So we are not any longer dealing with the chipset like mentioned at Trident and Tomahawk. We are jumping to so-called DNX family. And as you can see from the left, we have so smaller routers, 24, 25G with 2 times 100G, 2 times 400G. And those last interfaces, from both vendors, from EdgeCore and UFI, can support ZR+. In the middle, we have an older brother. It's powered by the Qumran second generation Q2C. And that model is coming with also 2 ports which can support ZR+, but in total we have four times 400G, but those last interfaces, they are coming with a higher budget. It is also quite nice design. And on the right side, same chipset, different vendor, different port count. It is, I would say, a really interesting model. We have some 1G, 10G, 25G interfaces, but the most important, it's coming with 24 times 100G and 4 times 400G. And all of them can, again, support ZR+. And when before we were discussing about the switches, now we are really talking about the routers. So based on the chipset spec and the different profile, some of them can definitely support the full routing table and even more. And jumping to the next, we have 2 extra models coming from UFI space. Another one with the Q2C. So this is like a bigger brother of the previous one. So we have 48 times 1G, 100G QSFP28 with 8 uplinks, again, supporting ZR+. And I would say our beast, this time Jericho 2C+, really interesting design, really powerful router with 36 times 400G. As you can see, those guys can support different port speed. But again, we are focusing today on the ZR+. So the 400G from those 32, 24 can support it. And as you see on that slide, there could be some thermal challenges. So, that need to be really tested and validated. But even with such as, I would say, really powerful design, we can support 24 with 24 watts, all the upper one and few selected on the that. But of course, the portfolio of IP Infusion and the hardware compatibility is definitely far bigger. Today, we have more than 40 different platforms. And even as we speak, there is a new porting on the way from both vendors, from EdgeCore, from UFI, on both, on that more data center type of devices, and also the routers, which we are presenting here. And jumping to the next one.
Łukasz,
And
sorry
Łukasz,
to interrupt.
Oh, so many questions. Very good.
Yeah, there are 2 questions actually related to the slides you already presented. So I'll start with the second one. And the second question is it only routers, or you can offer data center switches also? And the answer is yes, we can offer data center switches also. I mean, basically from Broadcom, there are 2 ASIC families that we support. You have the XGS. I think we presented this in the slide number 6, if you can go back. Yes, so we have here the Trident 4 family, the Tomahawk 4 and the Tomahawk 5 on the right side, both from UFI and EdgeCore. There are no pictures of the switches yet, but they are coming. So these are the data switches, the data center switches, XGS family, and what Łukasz presented in slides 7 and 8, you have the DNX family with the Qumran 2 and the Jericho 2 switches. And the other,
thank you.
yes, and the other question is, if all these switches can tune transceivers, is more detail available? How can this be done? And the answer to this question is yes. Basically, we are running more or less the same OGNOS on all the switches. So we are running the same NOS, networking operating system, on them. We are doing the qualification of the plugs with the operating system. And as long as the platform will support it, as long as the switch is able to power and you can plug it in, it's gonna work. Yeah. That's how it is. And about the more detail, how this can be done, Vince is gonna address this in few slides. I mean, he will just do a live demo so you can see exactly how you can tune it, how you can change the frequency and all that, the applications. And we have documentation, we have how-tos about this. Of course, we can provide documentation. We can provide any help.
Perfect.
Back over to you, Łukasz.
Yeah, thank you. And speaking about the open networking, as you can see, it's not only freedom from the hardware perspective, if we are talking about the server, those routers or switches. So with IP Infusion and the OCNOS, we also have a really wide freedom to choose preferred coherent vendor. And that was already mentioned by Marian in the beginning. So at the moment, there is a list of the qualified optics from Sienna, Coherent, Fujitsu, Hennessy, Next, Smart Optics, and also some new coming soon. And on that slide, we just make a really simple table, which will show you what is the potential distance if we are just going from simple point A to B. And as you can see, if we are not amplifying anything with some of them, especially with a high budget, we can even go to 104 kilometers. So just imagine this, yeah? You have just two routers or two switches powered by IP Infusion and OCNOS. You are plugging one of those Sienna optics with a really nice budget, and in theory and also in practice depends on the quality of that fiber. You can go between 52 to even 104 still without any amplification. So when Marian was showing on the beginning, we already get rid of those transponder. Yes, that is beautiful, but we can even make it fully passive, yeah, in some lower distance. But of course, if you wanted to inject a little bit power, and in my calculation, I was just using like a typical amplifier with the gain of 22 dBs, we can extend that distance, if I will stick with those high power one, even to 280 kilometers. And of course, it's not everything, because we are still talking about only 0.8 and B. And as you know, you can also amplify in between. So really, we can go wider, yeah? So if you have any other modules which you are using at your universities as some kind of like a standards, I would say that first could be tried because the standard is quite open. And definitely it could be also qualified with the help of our gentlemen from IP Infusion. Because when I'm quite, I would say, older in that industry, believe me that I never ever saw any other partner with such a decent list of those optics. And again, we are only focusing on the ZR plus. If we will add ZR, it will be even more. Thank you. Or many questions? No, no questions. Good.
No, we'll come over and we'll just look at a brief picture, right? So we went over a lot of the benefits of why are we going here? Why are we using ZR plus? And we'll look at these configurations throughout a demonstration. So you'll have OCNOS at the border, interconnecting your campus, your data centers, your AI workloads. So building this across NREN networks or providers getting fiber, dark fiber, so you can light it, and then building your fiber rings, building your services on top, where we have rich feature sets like EVPN and segment routing that we're able to do quite a lot of service delivery across these backbone networks and provide the services that are required to do data center interconnect, move large amounts of data, and provide transparent services to customers, which customers at NRENs will be your university campuses and research facilities. Then we're going to take a look at changing the application code, which why would you change an application code? See, why not just 400 gig all the time? With lower bandwidth, you can go further. You can get better signal to noise ratio. With higher bandwidth, you're not going to be able to go as far. Maybe I'll let Marian say a few words about this here before I go into the demo.
Of course, yeah. So, well, do you want me to address it now, Vince? The distances, of course, the distances that Łukasz showed earlier about, he shared with, depending on the attenuation, from 50 going up to 100, of course, on the quality of the fiber, depending on the quality of the fiber, those distances are 400G to 400G. Now, when you lower the bandwidth, of course, you increase the reach. So if you're going, you can set it, as I said, the 400G ZR plus, you can set it even 100G, you will go at least double the same distance. Okay. So yes, it depends on the use case that you have. Okay, they can also interop. There are a lot of interoperability cases that we ran between them. So yeah, that's something that can be addressed. Sorry, Vince, go ahead.
Yep, no, appreciate it. So now we're gonna go over to our facility that's in PCSS in Poznan. So we have routers and switches from vendors as well as third-party test suites and equipment for being able to do this testing. So today we're going to be looking at a simple demo of 951028 DCs running Ocnos SP Plus with ZR Plus transceivers. We'll start with the default application, then this has 10 dB of attenuation since these are in the same rack, so it is point to point. And if you don't have some attenuators, then you might burn out your receive and you'll have very expensive paperweights. So if you're going to do point to point close by, make sure you use attenuators. Then we'll go to application code 9 and we'll take a look at this. So again, same setup. We're just going to change it on the fly within Ocnos and show how it comes online. So I'm going to stop sharing a slideshow now, and we're going to go over to the CLI.
And this is a live demo, so we are waiting for the crash. Yeah, good luck.
No, everybody always says don't do live demos. So we're going to test our luck here today, and we're going to do a live demo. Logging in to the devices now, and I will share my screen here. So everybody should see my terminal now. And the first thing we're going to look at is how do we see the information about the transceiver? So show QSFP DD0 EEPROM. This will show us the actual information about the transceiver, part number, serial number, characteristics, everything you're looking for. So some people look for this under the show interface CD0 transceivers. This isn't where you'll actually find that information because it's using the CMIS interface instead of the SFF. So everything will be done based on the QSFP DD0 or QSFP DD port number interfacing convention. So when you have a new transceiver and you plug it in, you can read the data sheet and get all the information about what you want to do from there. Or you can be like me and you just plug it in and you start using the CLI and see what's available. So we're going to do show QSFP DD0 application. This will show us what applications currently programmed into the hardware, and then what applications are available on the transceiver. So these will be different based off the transceiver, the vendor, and which applications are there. So show QSFP DD0 advertisement applications. And this is where we can find the various different application modes that we can set, which will give different characteristics for the links. So we're gonna, application 5 is 4x100, for instance. We're gonna configure application 9 here once we get through all of the verifications and information that we can see here on the transceivers. So see, this plug supports 12 different application modes. The other things we might want to look at the status of the laser. You can get information about your wavelength, grid spacing, laser frequency, channels, additional information here, or the media. So what are we transmitting at? What are we receiving at? And get that information that you might have looked on the show interface transceivers. It's under show QSFP DD0 monitors. See, and then that configuration is under QSFP DD. So this has a laser output of -5. If I want to go and make that back to 0, I can go here. No. Laser output power 0. This will bring it back to the default, which is no attenuation. And if I run the same command, we'll see that now it's launching at 0 for TX power. So you can also get a whole bunch of additional information here as to what's being received, things like prefect, effect, the SNR. There's a lot of valuable information. And there was questions about what can be configured. So our config guide will give a lot of that information, but just to see, you can have custom apps, laser power, loopbacks, you can change the application codes. You can really do a lot of different things. So like the fine tuning, the grid channels. So it's make sure we're not going to go through all those, but they are available on our webpage for the configuration capabilities. So I'm not going to commit anything here. I see the question coming in. So yes, OpenConfig support is available. If you follow, we're working with the Telecom Infrastructure Project. I think that's the TIP Mantra project for putting together OpenConfig and ZR Plus, as well as working with NTT on the ION project. See, now what we're going to do is we're going to change the configuration from application code 0, the default application code. We're going to take that over to application code 9. See here. See. We configure this under the interface application 9, and then we also have to do a breakout on the physical port to support the 3x100. So we'll put that there, and we'll configure the interfaces. Then we'll come over to the other side, and we'll configure the breakout and the application. Now the modules have to reinitialize. So while the modules are coming back online, I want to hand it over and just ask some discussion here with Marian and Łukasz about, what do you need to think about as you're doing planning for your optical system? Who can you go to for optical planning, and how can we assist with that process?
Yeah, I see a question coming.
Well, I think Marian's
read it.
Is Well, I just want to, before going to that, I just want to mention, since you spoke so much about applications, I want to add something. It's going to be very fast. I know that we are running a bit out of time, but when it comes to application, it's what differentiates the transceivers, let's say the variety of transceivers between them, you know. So from what we noticed, all the 400G ZR Plus are coming with default application 1 as 400G ZR. Okay. Now, when you interrupt two different vendors, 400G ZR, we notice that every single time it's going to work that. Okay. But when you are going into different apps from various vendors, yeah, everything else needs to match there. The bandwidth, as you see what Vince is doing here, 3x100. I think in your case, Vince, you have the modules are similar, yes?
Yeah, it's the same module
It's
on
the
both
same.
sides.
Okay, but if they would be different, as I said, everything else needs to match the bandwidth, modulation, and the frequency, of course, needs to, otherwise the frequency is mandatory for even if you're running the same vendor plugs. All right, Łukasz, you're saying?
No. So I saw that there was also one question. Maybe we can also address that. It is, if I am understanding that correctly, it is about the compatibility between the vendors and different coherent providers. So if this is something which is possible.
Yes, as I was saying, it is possible, but you gotta be very careful. I mean, you have OIF running these interoperability cases, you know, between various vendors, and this happens annually. But once again, you gotta be careful what you try to match. Yeah, that's how it is.
Okay.
Okay.
And we'll go through this as we are running a little short on time here. Is now that it's back online, so we'll show QSFP-DD 0 application. Now we can see that its application code 9 is installed. We'll have the same outputs on the other show commands that we had. So, and we can see that now we have 3 neighbors for ISIS instead of just the one link. So we're running 3 individual 100 gig connections here. You can bundle these together as to one aggregate instead of individual links as well. See, now I'm going to stop sharing again, and I'm gonna bring the slides back up, and we'll just bring it up for some, if there's any questions that
Actually,
are.
there is a question, Vince. Any samples or virtual environments available for testing?
Perfect question. Perfect question.
Yeah.
We have a
Pass
slide.
this over to Łukasz.
Yeah. So yes, the answer is yes. You can download like a virtual environment, virtual Oknos, and simply you just should go to either IP Infusion on our STORDIS website, and there is like a virtual various of the options, depends on the virtual environment which you are using. So this is like a one way. Of course, there are also some physical labs. The one where we are running as we speak, it is Poznań in Poland, but also I base in Poland as well. And as a STORDIS, we have our lab located in Leszno in Poland, but also in Germany, where our headquarters is located. So that is also something that we can arrange, like a remote access. So either you are testing that in the virtual environment, we can arrange physical environment with a remote access, or as you can see, we also do have like a mobile racks with the certification for vibration, which we can simply equip with either mentioned switches or routers, and simply send to you if you like to make your hands dirty. So yes, that is more than possible. There is another question. Okay.
And,
So if we are okay from the question perspective, I also prepare one question to all of you. Let me maybe put that also to the chat and also read it. I hope that I will do it correctly. So how many of you are currently experiencing bandwidth limitation in your university network? And, you know, whatever who is feeling that the bandwidth is not on the current level, please just feel free to drop a yes to the chat, and hopefully we will be able to help there. So maybe before we will wrap up, a very technical question to Vince. Vince, how young are you?
I turned 34 today. So
34.
Oh.
Okay. So I am 41.
What about yourself?
I am 41. Once again, happy birthday, my friend.
Happy birthday,
Happy-
guys.
Thank you to all of you, and really, we
Thank
are
you
looking
everybody for
forward.
joining.
Absolutely. All the best.